Okay, this is brute force.
That is brute force.
Hello, here are the guys from Germany. I am Thomas, and my guests today are Achim and Frank. Good morning, Frank.
Hello, Thomas.
And good morning, Achim.
Hello, Thomas. Hello, Frank. Hello, world.
So, who of you will explain me the puzzle?
Maybe we just start with the description of the problem. So we have landed on a lava island and are an array of very large mirrors. And in our puzzle input, each of these groups is one of these mirror arrays. And for the first part, we have to find lines on which these mirrors have a reflection with itself. So for the example, it's for the first mirror on this axis, on this line. So the left is the same as the right, whereas we can ignore the first column because we don't have it on the other side. So if we would find that column 1 is the same as column 2, that would also be recognized as a valid reflection, even if it is a very trivial one. Reflections can also happen horizontally. So in this case, the lower 3 lines have to be mapped into these 3 lines above, and the first again is out of the question, doesn't matter. And then we have to calculate the number of columns or rows above or left of that and add them together. So we take the sum of the number of columns to the left of each vertical reflection line and add the number of rows above each horizontal line of reflection times 100. That leads to the answer of the first puzzle.
Okay, some comments from Frank to this puzzle?
Well, that's the puzzle, like Achim explained.
Exactly. So I go into my code. Today I have only one method because I need the data from part 1 for part 2 as well. So it's in one method. So first we get the input. I break it down into distinct patterns. So each empty line splits is a separator between 2 patterns. And then on each pattern, I calculate the horizontal and the vertical reflection line. And for my puzzle input, I have exactly one reflection line for every single pattern. I believe Frank had in his puzzle input some parts that had no reflection line at all. But in my input, every pattern had a reflection line.
I'm not sure about this point, but maybe it was like that.
Okay.
So the constructor for my pattern class is very simple, just draw these lines. And then we are already going into the methods for finding the reflections. So the method horizontal reflection first looks for probable candidates that may be reflections. Because my first approach was just look for 2 lines directly adjacent to each other that are the same, and that's it. That's not good enough, but I kept that method anyhow. So it's very simple. Go through and examine if two lines that follow each other are the same. And with those results, I then go forth and verify them. So from the pair that I have, I go outward. So if I have a line I and I plus 1, in this case, it would be C and C minus 1 that are identical. Then also C plus 1 and C minus 2 have to be identical, and C plus 2 and C minus 3, and so on, until I run into the bounds of my pattern and cannot check any further. That's why I have this minimum function here, so that I have the maximum deviation that I need to go from the reflection line and check. Yes, that's it for the horizontal reflections so far. For the vertical reflections, I take the pattern and rotate it by 90 degrees. 90 degrees to the right. I do it here, so the top left corner becomes the top right corner. And on that, I do the very same, I do again the horizontal reflection calculation. So I don't need to build the calculation for the horizontal reflection again from scratch with additional errors that might occur. And so I get to the horizontal reflection as well. And everything else is already for part 2.
Okay, so you have to find the reflection for both sides for every pattern.
Yes.
Okay, and which one is used? Or both are used?
Both are used. But actually,
I can use both, but actually there is only one.
Yeah.
Okay.
If there were both a horizontal and a vertical reflection, I would use both, but there is no pattern that provides such.
Okay, I got it. So the trick is you have to move your input to 90 degrees. So transform 90 degrees your input and do the
and
same.
Then do the same stuff again. Yes.
Okay, nice. Comments from Frank, or can we go to the next part?
You can go to the next part.
Okay, what is the twist in part 2?
The twist in part 2 is we have done that story-wise to evade, to prevent running into any mirror that might be lying around, and we walk into the valley, and first thing we do, we crash into a mirror lying around. So the twist is that all of these mirror arrays have one mirror piece that is dirty, that has a smudge. So exactly one dot or hash of such an array needs to be flipped. But we don't really know which one. The only thing we know is that that exchanging that item leads to a different reflection line.
But actually, this is some some self-explaining information, because if you got a mirror before and then you change one char, then it does not mirror anymore. So the mirror has to be somewhere else automatically.
And if it doesn't, and if we change one field that prevents this thing from mirroring at all, we changed the wrong one.
Okay, and how to find the right character to switch?
How to find the right one? Yes. I have the method in my class called unsmudge.
Actually, the input is so that there can be only one of them. It's exactly one. So it's again, you just search for a mirror with unsmudge, and you will also find only one of them, like in the first star puzzle.
Okay.
If and only if you take care of the old reflection line and don't and prevent to be returned in the proper way. I had a little bit of a problem there. So what you can actually do is brute forcing that by trying every possible modification. So we take each pattern. So this is on the pattern class. So we take the pattern and then create copies of it, each with a different field flipped. Just one in every case.
Okay, this is brute force.
That is brute force. So what I've done here is I have a new list of strings to carry the pattern, copying over the old ones, and then replacing on one line one character. So I don't copy over all strings. I just copy the structure of the array and then fill in a modified string at one position. That saves a little bit of memory. Then I have the pattern, the modified pattern, and on that I again calculate horizontal and vertical reflection, and this is the point where this list result comes in, as well as this field here. In the methods for the first part, you see that I am detecting the result of the first pass, which is by chance in any case exactly one result. And in this list, I store the horizontal reflection lines as positive and the vertical as negative, with the idea of keeping them apart down here. So I go through every modification of the pattern, calculate horizontal and vertical reflection, put them into a set, and when I'm done, I'm removing the 0 entries. That means variations of the patterns that don't work because I don't care for them. And I also remove the old reflection line. If it is positive, it's a horizontal one. If it is negative, it's a vertical one. That's why I have a minus here to reflect it back. And the only possible solution that survives this torture can be the new reflection line and nothing else. And because I'm returning a single int here, I calculate here. I do at this point already the calculation horizontal times 100 plus vertical.
Okay.
And even if this is brute force, the entire runtime for both parts, including the test data, is 1 second.
Yeah, wow.
Okay, nice. So this brute force solution, like you wrote it down, has a lot of things in it which are actually not needed. So I implemented some kind of a trick here, and then my solution runs in 6 milliseconds. So the point is here, you got a definition of a reflection, and in the first star, this definition of a reflection is that both halves of the reflection are exactly the same, so there are 0 differences. And now if you think about the number of differences for the second star, the definition of this reflection in the second star says there's exactly one difference. So now instead of in this method where you check if it's a reflection and at a certain line, if you dare not simply return a Boolean true or false, but instead return a number of differences, then you can use this method for both the second and the first star. And then the second star is exactly the same code as the first star, and it's pretty simple. And this whole thing with horizontal and vertical goes more or less away, and you don't need to clumsy add up things here, but you can simply write it down. And then it gets very fast because you don't have to iterate all positions, but you do it only once for each map.
And you don't need to keep in mind the old reflection line because that is the one that returns a deviation of 0.
Yeah, actually, this with the reflection lines and these multiple reflections, this was fairly unclear to me for at least an hour. But after some times, if you think about it, there can only be one reflection line. And in the second star, if you change one char, then always this number of reflection line changes. And now if you consider no existing reflection line as a 0, then you can simply sum up the numbers and you never have to check how much of reflection line exists or something like that. Simply everywhere you find a reflection line, add up the numbers, and then you get the right result. So this makes it shorter, the solution, and quicker.
Okay. Last question to you both, starting with Frank. Frank, what was the hardest challenge for you this time?
Well, understanding the riddle. This is I found that the wording was kind of clumsy today. Understanding what was meant with mirrors and what happens if there's more than one possible mirror line, because this could happen, but in the input data it does not. So understanding this was pretty difficult.
And Achim, for you?
I had some problems processing the real data. And for part 1, I got very quickly to the real result for the test input, but then had problems in recognizing the real input because I excluded the trivial case that the first and second row, for example, if that they already might form a reflection line, because you have no surrounding environment that you have to check, and it seemed too easy.
Okay. Bye-bye, everybody, and see you tomorrow.
Bye.
Bye.